I'm Katie Wilkes, and today I'm going to share with you a few of the topics from a paper I co-authored with William Wilkinson called A Method for Updating Sparse Exploration Models with Current Mining Grade. Bill is with Datamine, and he's what I'm going to call a MineScape software expert. He helps us out sometimes up at the Smoky Canyon, where we use MineScape as our software for geological modeling and mine planning. I am the geologist at Smoky Canyon, which is a holding of the J.R. Simplot company. We're going to talk just a little bit about the geology of the region today, the different models that we use, and how we continually update them as we mine. The Smoky Canyon Mine is located in the southeast Idaho Phosphate District. There are several mines in operation in that region, circled in red on the image. This is a nice old simple map indicating the exposed outcrops of the Phosphoria Formation throughout the Rocky Mountain region. The Phosphoria Formation is a Permian-aged formation brought up through thin skin thrusting during the severe orogeny. The dotted line on this particular image indicates more complex structure to the west and more simple structure as you get into the basins of Wyoming on the east. The more complex region includes an area also known as the Fold and Thrust Belt. This is the area in which we are operating. This more localized image shows the traces of many thrust faults in this region as they propagate from the west to the east. The section D goes very near the Smoky Canyon Mine and is also on this slide. You can see the thrusts, the different faulting, folding, overturned beds, really fun geological region, structurally speaking. Of course, if you're trying to model it, maybe not as fun. Well, fun, but just a little more complicated. And that's about all we're going to discuss today about the geological region. The Smoky Canyon Mine itself opened in 1983 and began shipping its ore slurry via a pipeline to the Don plant in Pocatello, Idaho. There they create many fertilizer products for use in the agribusiness sector. They've been mining ever since and are currently operating in panels F and G on the image. The other panels are mostly mined out and reclaimed. This is a typical cross-section of the open pit mine design at Smoky Canyon, very simplified. The Meade Peak member of the Phosphoria Formation is the ore-bearing unit within the formation that we're looking at. The red and pink are the ore that we're going after with more of a lower grade inner burden of center waste between. It's overburdened by the Rex-Chert member of the Phosphoria Formation, and depending on the pit design and topography, might have some Triassic Dinwoody overlaying that in this region. The Wells Formation limestone makes up the footwall, which we try and follow the dip of that down through the pit. This image correlates pretty well with this image, with the high spiky upper and lower ore zones shown, if you kind of turned it on its side, and the lower grades not quite so high, with the overburden and underburden not registering too much with a gamma count. This is a single exploration drill hole as a typical drill hole gamma log. This is what we start with our exploration models. You got to start somewhere, and sometimes we have very few holes and they might be spaced oddly wherever you can get a drill rig. Some of them are a lot older than me. Some of them I've drilled, but you got to start somewhere, and this is where we start. You take this typical gamma and you can identify your different contacts and your different thicknesses of each of your ore seams, and you put it together and tie them together as best as you can, put together your best song and dance, and realize it's still only a model. No matter how confident you are in the data that you have or how much data you have, we know all models are wrong, and we got to realize this. But moving on and trying to get the best product that we can, we start with our exploration model based on those drill holes, the logs we have, and the gamma logs that you just saw. Then we get our samples back from the lab. We might adjust the thicknesses of our seams, throw in anything else that we can get our hands on to our update model to try and create a better product. We use trench sampling as our ore quality method, so we'll try and take all the data that we get from that during mining and put that into the update model, and likewise with the quality model, which is kind of its own entity, throw in anything we can get our hands on and move forward with that as we go. We are in a stratigraphic deposit, so we will start with a stratigraphic model. Some areas might be a little more complex, too steep, faulted, too overturned for an upright stratigraphic model, so we might create some wireframes, tie that in with the strat model when we convert it into a block model, which with MineScape is a nice easy point-click process. Then once we have our block model the way we want it, we'll interpolate our quality into that. You can do this with a stratigraphic model as well. There's just a few more options currently with the block model to interpolate your data. So that's kind of the reason we've gone in that direction. This image on this slide is the block model visualization tool. I've got some topography up there with the block model thrown in. I've got it kind of pulled back and down so you can get into the model and see what it looks like on the inside. It's pretty handy for validating your model, and you can look at each of the little individual blocks and see what attributes are associated with each of those blocks. It's kind of a handy tool and nice image. As I was mentioning, we use our trench sampling as the basis for our ore quality control. We will take a dozer and just rip a trench on every bench through every ore seam or whichever ore zone is exposed on that level, and try and rip these about every 100 feet apart along the strike. And then our ore quality folks will stake the tops of each of the seams and take a composite sample, which they then use to determine the location on the stockpile where those seams are hauled. Our dozer operators clean these off based on the stakes and are really good at identifying the ore. Good luck, even as a geologist, you got to respect what these guys can do as you look at that image there. So that's just the basis of the trenching itself. Then you want to take this data and incorporate it into the model, because this is the actual way that we mine and where the ore actually goes to on the stockpile. So you can't really do much good for planning if your model doesn't reflect anything of the way you actually mine. So I'll take this trench data and update both the structural and the quality models. I'll add each of those surveyed top stakes you saw on the previous screen into the schema for the strat model as survey, and then I will create tiny little itty-bitty drill holes for each of those different seams, which I can add into the quality model. The reason, of course, you want to add more information for better models, but this is the exploration drill holes in one of our simpler pits. And this is actually a really well drilled out pit for some of the stuff we're usually dealing with. But each of those drill holes represent, or even the points within those, only cover about more than 3 acres per data point. When you add in your trench data, you have something representing 0.14 acres per data point. So you're getting a lot tighter model, more information, better product. The little itty-bitty drill holes I was talking about, I just take a spreadsheet and take the horizontal thickness measured between the stakes, convert it with a assumed dip, whether it's something I can measure, or as we're getting into a pit, possibly an attitude taken from the surface, and converting it into vertical drill hole so that it's consistent with the other quality data that I'm putting into it. And each of those little drill holes has their own little name. So the reason I don't use those drill holes in the structural model is because, as we were discussing the geological region earlier, you might have local differences within the dip, some structures in there that might throw things off, your interpretation versus your ore quality folks' interpretation. And I figure you're still getting more data inputted into your structural model with just the surveyed points on top than trying to include all these little bitty drill holes. And of course, you don't have a top and a bottom if you're looking at a stratigraphic model. So, and you're just basically putting your own error into it at that point. So I don't use those in the structural update, but I create them for the quality model. Now, you can take these new data points and lump them into your quality as is, or you can use them discretely. Example here, basically I'll take the P205, which is our key attribute, and use everything I have calling it itself, all the drill hole samples and the trench samples, and then I'll take and put a prefix for drill holes and trenches to kind of keep them separated. Reasons for doing this, to validate your exploration models and possibly come up with a dilution factor. As an example, you have a nice clean composite sample associated with the seam on a trench where it's exposed and you can get it. As you're drilling, your sample might not be right within the seam, it might be on the edge, and you're getting a little dilution from the hole. You might have an older drill hole where you're not using a reverse circulation, or you might have a core hole where you have identified it better, or your interval might be 2 foot here or 5 foot here. There's all sorts of things that you might not trust, and you can create a dilution factor or determine what kind of dilution you have between them. A lot of times in the past, we said, okay, well, of course the trench sample's too high, but by the time we get the ore all cleaned off and hauled to the stockpile, you're getting some dilution anyways, no matter how good the dozer hands can clean out the seams. So then it goes back to about the same drill hole quality from the dilution within the drilling. But is that really true? It's just an option to do more. And if you come up with a factor, you can apply it to your drill hole data or to your trench data, or for just short-term reasons, you can just lump everything in and kind of come up with a nice average between all of these and go with that. Whatever you decide works best for you. Another reason you might want to have these different prefixes, and you might actually add prefixes to different holes, or because sometimes you have discrete samples of depth samples in a drill hole, and you've taken and created the seams and then composited those in the lab physically, and then ran different attributes like BTUs or your other metals that are just composites, and you don't have them sampled, discretely to save some money. So you might have some issues, of having multiple samples of the same hole overlap. So you can create more drill holes, more prefixes, suffixes. You can add whatever you need in there to make it work for you. But that's just the background to that. So now we're not looking at the model anymore because we've made it to the stockpile. And of course, you're probably going to be sampling the stockpile to verify the grade for your mill feed. And you've been hauled here based on the trench samples. And that's where you're at. So the reason for putting all of this together is so that you can actually balance your stockpile. If you're doing a blend where you use part of each of these different grade bands in your stockpile, you need to plan so you have them balanced and you're not running out of what you need for your blend. So this is why we need to incorporate this into the model and keep up with it. This is an example of the expression that we use to identify the different stockpile bands in our mine. You can, if you have certain seams that you notice certain properties of that you might want to segregate for whatever reason, you can include them here and the grade bands and code them. Here I have our gold, red, green, blue, and gray for waste. You'll want to include something for stuff that's not within your cutoff area. And you can use these expressions in the block model for all sorts of different things. We use one for the density of different seams, for overburden, etc., and underburden, so we can get our tonnages right. You might have an engineer who wants a lithological order code so they can see everything in the order they want, or possibly you might want to run tons of equality, so tons P2O5, per block, or tons of, maybe mag, or something that you want to segregate out how many tons of it is associated with this area. There's lots of things you can do with expressions, and the folks at Data Mining with MineScape can help you out. If there's some different, format than just your regular Excel type of expressions. Bill's going to be here for questions afterwards as well. One note for any MineScape specific users, I have here gold, red, alphanumeric things. You could create a code for them to, like 1, 2, 3, 4, 5, etc. Instead of using a alphanumeric thing, because when you run the categorization reserves in MineScape, you can then include the code in this attribute with your other attributes, rather than having to put it in attribute tab, such as with the seam and the stockpile, like what I have done, where it's a word instead of a code. And that's just kind of a side note I had with that as we're wrapping this up. So of course it's a continuous process for improved prediction and planning. The more information you get, the more likely you're going to be able to track any of the trends you're seeing, especially as you start into a pit, as you're going down with depth, location within the pit, you're northing, easting. You might be able to identify some stratigraphic trends, from pit to pit. So this particular seam, changes with depth or location, more so than another. And you can also identify some structural influences that you may or may not have modeled. There might be some small faults in there that you're in this area and you've got some dilution or something, or maybe some alteration that's upgrading or downgrading your ore, and it's not something that you have modeled as a fault, but it's influencing something in there, and you can see that, and it'll help you as you go down if you keep up on this. And that's all I have. I believe Bill and I will be here for a little while to take any questions. And thank you for your time, and have a great day.